In this video, we're going to talk about how to divide radicals. So remember, we talked about using the product property to simplify radicals, and that worked when we had radicals that look like this, the square root of 40 x to the fourth y to the seventh. Well, when we have radicals with a fraction, simplifying is going to involve making sure that there are no radicals in the denominator. So if we're working with the square root of 25 over 3, we want to turn it into something like 5 times the square root of 3 over 3. So we're going to need the quotient property of radicals to do this. So if we have the square root of a over b, we can separate that and turn that into the square root of a over the square root of b. The same property applies if we're talking about taking the nth root. So we also are going to need those properties of exponents as we work on simplifying these radicals, especially the product of powers property and the power of a power property. So what we're going to be doing is called rationalizing the denominator. So in order to rationalize the denominator, you need to realize that if we have the square root of x times the square root of x, okay, remember the product property tells us that that means this is equal to the square root of the product of these two, so the square root of x squared. Well, if we take the square root of x squared, that's going to equal x. So if we have the fifth root of x squared times the fifth root of x cubed, okay, when we multiply these two terms, x squared times x cubed, remember we add the exponents, so we'll have the fifth root of x to the fifth. Well, the fifth root and x to the fifth will cancel each other out and we're left with just x. So this kind of shows us that there is a way to multiply a radical by another radical in order to get rid of the radical, right? Because notice that these products don't have a radical in them. So we can use this idea to rationalize the denominator that helps us get rid of the radicals in the denominator. So let's look at an example. So suppose we're trying to simplify 5 over the square root of 6. So this is not simplified because remember we said that we can't have radicals in the denominator. Well, if we think about it, if we take the square root of 6 and multiply it by the square root of 6, we'll get the square root of 6 squared, which is equal to just 6. And that gets rid of that radical. Well, remember, if we have a fraction, we're allowed to multiply by any form of 1 over 1. Right? As long as we have the same numerator and same denominator, we're not changing the actual fraction itself. So what if we took this 5 over square root of 6 and multiplied by the square root of 6 over the square root of 6 in order to rationalize the denominator? Well, remember, we multiply the numerator, so in the numerator we get 5 times the square root of 6, and then in the denominator we have the square root of 6 times 6, which is 36. The square root of 36 is 6, so this leaves us with 5 square root of 6 over 6. This is the fully simplified form of this original fraction because notice that there are no radicals in the denominator. So that's what we're going to do today. So we're going to start off by rewriting the expressions that we're working with using the quotient property. Then we'll determine what expression needs to multiply the denominator in order to eliminate any radicals in the denominator. Then we'll turn this expression into a form of 1 over 1 and multiply it by the original expression. Then we'll multiply the fractions using the product property and simplify whenever possible. So let's start off with this example. So we have the square root of 3 over 5x. So what I'm going to do is I'm going to start off using the quotient property to rewrite this. So I'm going to write this as the square root of 3 over the square root of 5x. So now I need to work on getting rid of that radical in the denominator. Well, since this is a square root, if I turn that denominator into the square root of 5x squared, I can actually get rid of that radical. So I'm going to multiply by the square root of 5x over the square root of 5x. So in the numerator, that's going to give me the square root of 3 times 5x. And then in the denominator, I have the square root of 5x times the square root of 5x. So this is basically the square root of 15x over the square root of 5x squared. Okay, so in the denominator, since I have the square root of something being squared, I can cancel out that radical. So I have the square root of 15x over 5x. Okay, and this is now fully simplified because I do have a radical in my final answer, but it's in the numerator. As long as it's in the numerator, that's okay. So now let's try this example. So I have the square root of x to the 6th over y to the 7th. So I'm going to start off using the quotient property to separate this. So I have the square root of x to the 6th over the square root of y to the 7th. So now I need to turn that y to the 7th into y to the 7th squared. So I can multiply this by the square root of y to the 7th over the square root of y to the 7th. So in the numerator, that's going to give me x to the 6th times y to the 7th. And in the denominator, I have the square root of y to the 7th times itself, so y to the 7th squared. So when I simplify this, I have the square root of x to the 6th y to the 7th over y to the 7th. Now you can go ahead and pause the video and try doing this example on your own. So here, notice that we have the square root of y to the 5th in the denominator. So I'm going to multiply by the square root of y to the 5th over the square root of y to the 5th. In the numerator, that gives me the square root of x to the 9th y to the 5th. And then in the denominator, I have the square root of y to the 5th squared. So when I cancel this out, I have the square root of x to the 9th y to the 5th over y to the 5th. So now let's try simplifying this. So notice here I have a fourth root, okay? So I can use the quotient property to separate this. So this is the fourth root of 6 over the fourth root of 5x. So now I need to think about what I need to multiply by in order to turn this into a fraction without a radical in the denominator. Well, let's think about this. If I have a fourth root, the only way to cancel out a fourth root is if I have like a power of 4, right? Because the fourth root of x to the 4th will equal just x. So how do I turn this 5x into a power of 4? Well, we think about this. This is basically a 5 to the 1, x to the 1, right? So I need to multiply by something and then turn this into 5 to the 4th, x to the 4th, right? Because both of my terms need to have a fourth power in order for the fourth root to cancel out those exponents. Well, remember the product property tells us that a to the m times a to the n equals a to the m plus n, right? So we end up adding the exponents. So I need to figure out 5 to the what multiplied by 5 to the 1 is going to give me 5 to the 4th. Well, 1 plus what equals 4? Well, 1 plus 3 equals 4, right? So I'm going to multiply by 5 cubed. I'm going to do the same thing with x because 1 plus 3 equals 4. Well, remember, since this original term is under the fourth root, I need to put this monomial that I figured out under the fourth root, right? So I'm going to multiply by the fourth root of 5 cubed x cubed. Okay, so I'm going to multiply the same thing in the numerator, and that's how I'm going to cancel out that fourth root. So when I do this in the numerator, I'm going to get the fourth root of 6 times 5 cubed times x cubed. And then in the denominator, that's going to give me the fourth root of, you see, I add the exponents now, right? I have 5 to the 1, 5 to the 3rd, so that's going to give me 5 to the 4th. Same thing with x. X to the 1 times x to the 3 is going to give me x to the 4. Okay, so now I'm just going to make this look a little bit better because we have 6 times 5 cubed, and obviously I don't want to leave it like that in my problem. So that 5 cubed, remember, is 125. So I have 6 times 125x cubed. And that's over, well, in the denominator, these fourth powers are going to get canceled out with that fourth root. So I just have 5x. So now let's just combine those two coefficients in the numerator. So just it looks a little bit neater. So I have the fourth root of 750x cubed over 5x. And that is the fully simplified form of this expression. So now you can go ahead and pause the video and try doing this example on your own. So when we do this problem, we have a fifth root, right? So we separate this and this turns into the fifth root of 3 divided by the fifth root of 4y. So what we need to do is we need to figure out, well, what do I need to multiply here to get this fifth root to cancel out? So I need to multiply by 4 to the 4th, y to the 4th. So I do the fifth root of 4 to the 4th, y to the 4th, over the fifth root of 4 to the 4th, y to the 4th, and multiply by my original fraction. So in the numerator, that gives me 3 times 4 to the 4th and the y to the 4th. And then in the denominator, I have the fifth root of 4 to the 5th, y to the 5th. Because remember, I add those exponents together. So in the numerator, I just make that look a little bit better. So that 3 times 4 to the 4th, I did that on my calculator and got 768. And then that y to the 4th. And then in the denominator, just have 4y. So whenever a radical expression involves a fraction, it needs to be simplified by rationalizing the denominator. This ensures that there are no radicals in the denominator.